Every electronic device you use, phone, laptop, even satellites, all depend on controlling current. And the simplest element that does this job is the resistor. What is a resistor? A resistor is a passive two-terminal electrical element that opposes the flow of electric current and dissipates electrical energy in the form of heat. It is a passive element and can only absorb power. Think of it as traffic control for electrons. Ohm's law states that for a linear bilateral conductor, the current flowing through it is directly proportional to the potential difference across its terminals, provided physical conditions remain constant, such as temperature. That is, V equal to IR, where V is the voltage, I is the current, R is the resistance. Increasing the electrical push, that is voltage in this case, increases current linearly. Increasing the atomic constriction, that is R, forces current down. If temperature changes, the linear relationship breaks down. Resistance of a conductor. Resistance of a uniform conductor is the property which opposes the flow of electric current and depends on its material length and cross-sectional area. That is, R is given as rho L by A, where rho is nothing but resistivity, L is the length of the conductor, and A is nothing but cross-sectional area. A longer wire means more internal atomic collisions, increasing resistance. A thicker wire provides a wider path, easily flowing and decreasing resistance. Resistivity is the inherent property of a material that quantifies opposition to the current flow, while conductivity is the reciprocal of resistivity. That is sigma equal to 1 by rho, where sigma represents electrical conductivity. Copper has very low resistivity, making its conductivity exceptionally high. Insulators have high resistivity and near zero conductivity. Power dissipation. Electrical power in a resistor is the rate at which electrical energy is converted into heat energy due to the flow of current, where power P is given as voltage multiplied by current, which is equal to I square R, that is square of current into resistance, which is equal to V square by R, that is voltage square by resistance. Known as Joule heating because power scales with the square of current. Resistors are said to be in series when they are connected end to end, such that the same current flows through them, and in parallel when they are connected across the same two nodes sharing the same voltage. R equivalent for a series circuit is given as R1 plus R2 plus R3, while 1 by R equivalent for a parallel circuit is given as 1 by R1 plus 1 by R2 plus 1 by R3. Voltage divider rule determines the voltage across a resistor in a series circuit. Based on the voltage divider rule, for a series circuit, voltage V1 is given as V into R1 divided by R1 plus R2, and current divider rule determines the current through a branch in a parallel circuit. And as per current divider rule, we have for parallel branches I1 given as I into R2 divided by R1 plus R2. Resistance of a conductor changes with temperature due to variation in atomic vibrations, and this variation is approximately linear over a limited temperature range. That is, resistance at final temperature T, RT, is given as R0 into 1 plus alpha into delta T, where R0 is baseline resistance at reference temperature T0, alpha is temperature coefficient of resistance, and delta T is temperature change, that is T minus T0. Metals have a positive coefficient, that is alpha greater than 0. Heat causes atomic lattices to vibrate violently, blocking electrons. Semiconductors have a negative coefficient, that is alpha less than 0. Heat frees locked charge carriers, aiding flow. Once you master resistors, circuit analysis becomes pure algebra.